We've already seen that if you're travelling down a river at 6 metres per second and I'm running along the river bank at 8 metres per second, then my velocity relative to you is 8 minus 6, which is 2 metres per second. We can use vector notion to generalise this. My velocity relative to you is equal to my velocity relative to a stationary observer minus your velocity relative to a stationary observer. This works with other vectors too. Take, for example, position. Suppose that I was at the displacement 2, 1, and suppose that you were at the displacement 1, 4. Your displacement relative to me would be displacement of you relative to me is equal to your displacement minus my displacement, and that's equal to 1, 4 minus 2, 1, which is equal to minus 1, 3. This is just simple vector addition, and it's most easy to see if we draw the vectors. So xy, your displacement, 1, 4, minus my displacement, so minus 2, 1, is equal to your displacement relative to me. So xy minus xm is equal to xym. So what else can we do with vectors? Well, instead of addition or subtraction, we can multiply them. We can multiply them in two ways: the dot product or scalar product and the cross product or vector product. Let's start with the dot product. The dot product of two vectors is found by multiplying them component by component and adding the results together to get a scalar. So, for example, if A is the vector 1, 2, 3, and B is the vector 4, 5, 6, then the dot product of A and B is written like this: 1, 2, 3, dot 4, 5, 6. Then we multiply component by component and then add. So that's 1 times 4 plus 2 times 5 plus 3 times 6, which is equal to 4 plus 10 plus 18, which is equal to 32. The dot product of two vectors is defined as A dot B is equal to the magnitude of A times the magnitude of B times by cos theta, where theta is the angle between the vectors A and B. So, for example, if A is equal to 1, 1 and B is equal to 0, 1, then we can find the angle between them. So the dot product is 1, 1 dot 0, 1, which is equal to 0 plus 1, which is equal to 1. The magnitude of A is given by Pythagoras' theorem, so it's 1 squared plus 1 squared, all square rooted, which is equal to root 2. And the magnitude of B is just simply 1. And so that implies that cos theta is equal to A dot B divided by magnitude of A times magnitude of B, which is equal to 1 divided by root 2, which implies that theta is equal to 45 degrees. And if we plot these in the Cartesian plane, we can see that they are 45 degrees apart. The dot product's useful because if it's equal to 0, so if A dot B is equal to 0 and A and B are not 0, then it means cos theta must be equal to 0. And so if it is, it implies that A is perpendicular to B. The other way we can multiply vectors is using the cross product. So instead of getting a scalar, when we multiply them together in this way, we get a vector. So if we have the vector A and we define it as x, A, y, A, z, A, and we've got the vector B, which we define as x, B, y, B, z, B, then the cross product is worked out like this. So A cross B is equal to x, A, y, A, z, A cross x, B, y, B, z, B. And it's worked out as this term times this term minus that term times that term. So that's y, A, z, B minus y, B, z, A. That's the first component. The next component is this term times this term minus that term times that term. So that's x, B, z, A minus z, B, x, A. Then finally, the last term is worked out as xa minus yb, xa times yb minus ya times xb. xa yb minus xb ya. Okay, let's see how this is done with actual numbers. So let's define A to be 1, 2, 1 and B to be 3, 4, 0. So A cross B is equal to 1, 2, 1 cross 3, 4, 0, which is equal to 2 times 0 minus 4 times 1. Next component is 3 times 1 minus 0 times 1. And the final component is 4 times 1 minus 3 times 2. So this simplifies to minus 4, 3, then 4 minus 6 is minus 2. So this is significantly more complicated to work out than the dot product, and we also get a vector at the end. The cross product is defined if between A and B as being equal to the magnitude of A times the magnitude of B times sine theta where theta's the angle between them, times c, where c is a unit vector which is perpendicular to both a and b, and where a, b and c form a right-handed set. So what that actually looks like is a, b, c, a unit vector perpendicular to them both, the angle between them is theta, and so when we cross them we get a vector in this direction. What's useful about having the cross product is it lets us work out this normal direction, and it can also tell us when two vectors are parallel, because when a cross b is equal to 0 and a and b are not equal to 0, then sine theta equals 0, so that means a must be parallel to b.